does kind of involve, you know, knowing how multiplication and division are related, we're actually going to get into dividing today. So our first two problems here, we're dividing a polynomial by a monomial. So what that means is that we have three terms, because we have actually a trinomial here. So we have 1, 2, 3 terms, and we're going to divide each of those terms by 3x squared. So we're actually going to set up kind of 3 mini division problems, and here's what that could look like. So first we have 9x cubed divided by 3x squared. So that's this term right here divided by our monomial, minus 6x squared divided by 3x squared, plus 15x divided by 3x squared. So we're just going to take each of those 3 terms. If we had more terms or less terms, it would work the same way, and divide by this monomial. This is called the divisor, same as in a integer division problem. All right, and then we're going to simplify. So in our first term here, 9 divided by 3 is 3. X cubed divided by x squared is x. So you'll see we're going to keep using those exponent laws. Minus 6 divided by 3 is 2. X squared divided by x squared is 1, so we don't need to write it. And then plus 5. And then x, this is x to the first divided by x squared. So that's actually going to be x to the first in the denominator. All right, so we'll just write each of those 3 terms in simplest form, and that is the quotient. So when we take this polynomial and divide by this monomial, this is the quotient, which you'll remember is the answer to a division problem. All right, I'm going to have you guys do number 2 on your own, so set that up the same way, simplify, pause the video, check back when you're done to see if you got it right. All right, so looks like we should get 5 divided by 5 is 1, b to the 4th divided by b to the 3rd is just b. All right, so that first term is b, minus 15 divided by 5 is 3, b squared divided by b cubed is b in the denominator, and then 1 divided by 5b to the 3rd can't be simplified. So there we go. All right, we are going to review long division. All right, so we've got 528 divided by 32. So when we are performing long division, we want to see how many times does this number go into this number. Well, I know that 32 doesn't go into 5, right? This is 2 digits and this 5 is only 1 digit. So I'm going to expand and I'm going to look at 52. So how many times does 32 go into 52? Just once, all right? And then that would be 32. So I'm going to subtract to see what's left over. 52 minus 32 is 20. All right, 32 doesn't go into 20, which is good because, sorry if my voice was lagging on the audio or on the video there. 32 doesn't go into 20, which is good because that would mean we didn't have the right number up here. So I'm going to bring down my, whoops, too far. I'm going to bring down my 8. Whoops. All right, now 32 goes into 208. Well, I'm going to have to do some guess and check here. So I'm going to take out my calculator. All right. All right, so 32, I'm going to try times 6. That's 192. That was a lucky guess. All right, so I now know, because I'm not going to be able to fit another 32, right? If I added 32 to that, it would be 224. So I know that 32 times 6 is 192. So that means that 6 is how many times? And that's 192. So I'm going to subtract to see what's left over. That's going to be 16. All right, and now 32 cannot go into 16. So I have a couple of different ways I can write this, okay? I have 528 divided by 32 is 16 with a remainder of 16. So that's one way. 16 with a remainder of 16. All right, another way is I have 16 and 16 30-seconds. So this number is half of that number. So I can actually simplify in a third way, a better way, and I can say 16 and a half times. And then another way is I could say, lots of ways we could write this, and one of these last two is going to be the best way, 16.5. All right, so this is probably the way you first learned when you did long division. And then as we get more comfortable with fractions, we ideally are going to want to use something like this. You might also see an improper fraction. All right, so using that, we're going to try just number 4, long division on polynomials. So I wasn't able to put this in there, but we're going to need to put in our division symbol there. So I couldn't copy it in there. It looks just like this one over here. All right, and we're asking ourselves the same question. How many times does x minus 1 fit in here into this polynomial? And I'm only looking at the first term. So x, how many times does x, or what do I need to multiply x by to get x squared? Well, I would need to multiply by x. So, right, x times x is x squared. So I'm going to take this and multiply it by this entire divisor here. So just the same way that when I decided that 32 went in 1 time to 52, I subtracted 32 because that would have been 1 times 32. I'm going to do the same thing here. So x times x is x squared, x times -1 is -1x, and now I'm going to, let me get a different color real quick. Now I'm going to subtract this whole thing. All right, so x squared minus x squared, that cancels out. -7x minus -1x is -7 plus 1, so -6x. And now same thing that I did when I brought down this 8, I need to bring down my plus 10. All right, now I'm asking myself similar question. How many times, or what do I need to multiply x by to get -6x? Well, that would be -6. -6 times x is -6x. -6 times -1 is +6. Same thing I just did. I'm going to subtract this entire thing. -6x minus -6x cancels out. 10 minus 6 is 4. And now I'm at the point where I was right here, where x doesn't go into 4, right? There's no variable terms left over for me to work with. So this is my remainder. Now, just the same way we had multiple different ways of writing our remainder over here, we do when we have polynomial division as well. So my quotient is x minus 6, right? This is my quotient. It's my answer. But it doesn't go in evenly, so it's not just x minus 6. It's x minus 6 with a remainder of 4. But we're definitely not going to leave it like that because that is not the Algebra 1 way or Algebra 1 Honors way of leaving that. All right, so if we have a remainder of 4, well, it's 4 out of x minus 1, just the same way that this was 16 out of 32, right, because we were dividing by 32. So this will be x minus 6 plus 4, because it's +4, divided by x minus 1. So this 4 out of x minus 1 is very similar to this 16 out of 32 that we wrote over here. Obviously that could be simplified to 1/2. We can't simplify this at all, so we'll just leave it like that. And that is how we would write the answer to this division problem. All right, we're going to pause there, or stop there rather. We'll do 5 and 6 together when you get to class.